Hi everyone, this is Algebra 1, Topic 6, Exponents and Exponential Functions. So in this topic, we'll think about how we can use exponential functions to model situations and solve problems. You would wonder, what is an exponential function? We'll start with that. So in this topic, we have 5 lessons total. Some topic vocabularies include asymptote, compound interest, constant ratio, decay factor, exponential decay, exponential function, exponential growth, geometric sequence, growth factor, and rational exponent. We'll learn one by one. We have a STEM project related to called Big Time Payback. Most people agree that investing your money is a good idea. Some people might advise you to put money into a bank savings account. So you're going to think about saving your money, investing your money, invest in the stock market, buying bonds. So is bank savings account a good way to let your money grow? You'll investigate that. Okay. Yeah. So your task is to predict the future using Moore's law. All right. And this is the first lesson of topic 6. Exponential, rational exponents and properties of exponents. So in this lesson, we'll use properties of exponents to solve equations with rational exponents. Key vocabulary in this lesson is rational exponent. Let's start with critique and explain. Students are asked to write an equivalent expression for 3 to the negative third power. Okay. Cassie and Jacinta each write an expression on the board. Cassie thinks 3 to the negative third power is equal to negative 27. Jacinta thinks 3 to the negative third power is equal to 1 over 27. Who do you think is right? Cassie or Jacinta? So this is A. Okay, how do we know? So what are the things that you already know that look similar to that? You know powers, right? 3 to the third power. What is 3 to the third power? That means you multiply 3 times 3 times 3. And so that's 9 times 3, 27. Okay. What about, let's explore more. What about 3 to the second power? 3 times 3, so that's 9. What about 3 to the first power? That's just 3, right? So do you see what's going on? 3 times 3 is 9 times 3 is 27. So every time your power goes up, you times it by your base. Every time your power goes down by 1, 27 to 9, you divide it. If you go backwards, you divide it by 3, the base, right? So 9 divided by 3 is 3. So what is 3 to the 0th power? This is really, is it 0? No, it's 1. 3 divided by 3 is 1, okay? Then what about 3 to the negative 1? That means you divide 1 by 3 and you get 1 over 3. So can you already see? Can you see where we're going? 3 to the negative second power should be 1/3 divided by 3. So 1/3 times 1/3 is 1 over 9. That means 3 to the negative third power is 1 over 3 cubed, and that is 1 over 27. Jacinta is correct. Can you explain? Jacinta is correct because Cassie thought the negative exponent made 3 to the third power a negative number. But it makes a fraction. But let's specify. But the negative power makes a fraction. Okay. So this is part A. Okay, part B, what is the most likely error that was made? The exponent -3 means your base is not negative, but 1 is divided by the base 3 times, right? So, and since the base is positive, the base is 3, positive 3, your base still is going to be positive. So whatever is base, it keeps the sign for the base, but then your negative power will divide your base, okay? Instead of multiplying your base. So the exponent, this is a very common mistake, guys, means that 1 is divided by the base 3 times. Since the base is positive, the answer will be positive. Okay, so if you remember this, it's hard to make a mistake in exponents. All right, so think about what the properties are of rational exponents and how they're used to solve problems. Let's look at example 1. Write radicals using rational exponents. So look at this example 1. What does 3 to the 1/2 equal? What if your power is a rational number? What if it's a fraction? What does it mean? You can think of exponentiation as repeated multiplication, right? So start with the basics. Let's think about what the power is. What does the power do? The power multiplies your base by itself that many times. So if your power is 2, multiply your base 3 by 2 times. So 3 times 3 and so on. But what does the rational number, the fraction, mean in the power? You cannot multiply 3 half times. What does that even mean, right? So thinking about the definition of power and the exponents, the repeated multiplication, it doesn't really work in this case, but you have to define a new meaning for the rational numbers. So you're not gonna define like crazy rule. You're gonna follow the same rules of exponents. Power of a power property like that. So use the power of power property. What if we multiply the power by 2? Then you get a power of 1 and then you get 3. But we can't just multiply the power by 2. It's going to change the answer. So how do we undo that? Right? How do we undo that? The opposite of square would be a square root, right? So think about the powers and the square root. 3 square is 3 times 3 and 9. And that means 9 square root is 3. Okay, the square root and the power, this is a square root. There's an index number. If it's invisible, it's 2. So square root and the power of 2 cancel each other out. So then you get a base. That means we can say that the power, the rational number, is actually the same as the square root. So what does that mean? 3 to the 1 over 2 is actually square root of 3. Can you think what 3 to the 1/3 would be? In the same way, 3 cubed is 3 times 3 times 3, and that's 27. So how can you make 27 a 3? By cube rooting 27, and you get cube root of 3 cubed, and the cube root and the 3 power of 3 cancel each other out as long as they have the same number. The power and the index number of your square root is the same, they cancel each other out. So you get a 3. So the power and the square roots are the opposite. They do opposite operations. So 1/3 power actually means the cube root of your base. Does that make sense? So whenever you get a fraction in your power, don't freak out. It's just a square root. Okay? So what if you get something like 3 to the 2 over 3 power, just like this? That means you can write this as 3 of 2 times 1/3 of a power, right? So that's really what? Cube root of 3 squared. Okay, does that make sense? Or you can think of it like this. You can put a parentheses. It's a power of power. And so you can make the 3 square into a cube root. Or it's the same as, that could also be written as 3 to the power of 1/3 times the power of 2, right? So then that could also mean you can write this as cube root of 3 squared. They're actually the same thing. They're gonna be the same thing. Okay, so try number 1. What does 2 to the power of 1/3 equal? Can you explain using your own words? Okay, are you ready? So 2 to the 1/3 in the same way should be cube root of 2. Why? Using this rule, we know that the denominator of the fractional power, fractional exponent, becomes the index of the radical, while the numerator is the exponent of the radicand. Okay? So the radicand is the base. It's the same of the base of the exponent. But when we have the radical number, which is the square root, that's when we call the base is the radicand. Okay? All right, the next page, example 2. Use the product of powers property to solve equations with rational exponents. What's the solution of 3 to the power of x over 2 times 3 to the power of x over 3, which is equal to 3 to the power of 9? Now that's kind of challenging. That's another level, right? So you already know how to do this. You just need to think about it step by step. You know the product of powers property. where, so do you guys remember all the exponent rules? Maybe it's a good idea to review the exponent rules, all the exponent rules before we actually jump into the operation. So exponent rules. This is pre-algebra stuff, but it's okay if you don't remember. So the quotient rule says that if you have the same base, so 2 to the power of 2 times 2 to the power of 3 and different power, you can add them. 2 to the power of 2 plus 3, you can add the powers because you're going to multiply the same number of times. 2 times 2 times 2 times 2 times 2. That's equal to 2 times 2 times 2 times 2 times 2. That's equal to 2 to the 5th power, right? Yeah, that's the quotient rule, okay? And then we have the power rule. The power rule says if you have a base with a power on top of a power, then you can multiply your powers 2 times 3. And that's 2 to the power of 6. Okay. And then we have the negative exponent rule, which means if you have a base with the negative exponent, you change it to a fraction with the same power, which is positive of the opposite power. Okay. And then the last one is the zero exponent rule. Zero exponent rule. If your base is to the 0th power, all base with the 0th power is 1. 3 to the 0th power is 1. 4 to the 0th power is 1. Okay, everything is 1 if you have a 0th power of 0. Okay, so remember those rules. We're gonna use those rules to figure this out. So using the product of powers property. So the second one, product of power. You could just say power rule or the product of power rule. That means when we have the same, oh, wait. We have another rule. I'm sorry. It's a separate rule. If we have a product of powers, we have the same base, 2 to the power 2 times, wait, yeah, it's this one, the quotient rule. Sorry, that's the quotient rule. I think the properties, the names are different, but that's okay. Quotient rule or the product of powers. Oh wait, that's not quotient. This is product of powers rule, and then the quotient is the different one. I'm sorry. Quotient is when you have 2 to the power of 2, or just any base to the power of 2 divided by the same base to the power of different number, then you can subtract the powers from the numerator with the denominator power, the power of the power that's in the denominator. Okay, and so that's equal to 2 to the negative first power. Okay, so product of powers is this one. If you multiply the same base with different powers, then this one, then you can add the powers, add the exponents. So here, 3 to the x over 2 times 3 to the x over 3. The powers are different, but we have the same base. So we can use the product of powers and say that's going to be 3 to the x over 2 plus x over 3. Okay, that's on the left side. And so you can add them, you can simplify them. That's just really going to be 3x over 6 plus 2x over 6, right? Because x over 2 plus x over 3 is equal to 3x over 6 plus 2x over 6 if you rationalize the denominator. And then if you add them, you get 5x because x terms are like terms. You can add them. 3x plus 2x is 5x over 6. And so you have 5x over 6 as a power. And if your bases are the same, the exponents should be equal to each other if the numbers are equal, right? 3 to the something power is equal to 3 to the 9th power, which means there's only one answer for 3 to the 9th power, right? So that power, that exponent must be equal to 9. So you can just get rid of the base here and say 5x over 6 is equal to 9. And now you can just solve for x. Multiply 6 on both sides and divide 5 on both sides. And you get 54 over 5. X is 54 over 5 or 10 and 4 over 5. Okay. All right, so let's look at try it. What's the solution of 2 to the power of x over 4 times 2 to the power of x over 6, which is equal to 2 to the 3rd power? See if you can do it by yourself. Solve it by yourself and come back when you're ready for answers. Okay, are you ready? Let me zoom in. Okay, so using the same method, you're going to use the rules of exponents to figure this out. So you have the same base 2 here. And so that means you can also use the product of powers property and add the powers together. So this is equal to 2 to the x over 4 plus x over 6 is equal to 2/3, right? So you're going to add the powers. X over 4 plus x over 6 is equal to, rationalize the denominator, and you get 6x over 24 plus, or you could, the LCM is 12. So why don't we make it 12, okay? So 3x over 12 plus 2x over 12, right? And that's gonna be 5x over 12. So this is really 2 to the, so let's write the equation over here. That was the work. So 2 to the 5x over 12 is equal to 2/3, which means 5x over 12 must be equal to 3, right? So solving for x, you're gonna multiply 12 on both sides. And you get 36. Divide 5 on both sides, you get 36 divided by 5, which is 7.2. So x is equal to 36 over 5 or 7.2 is your answer. Okay, if you got it correct, good job. All right, example 3, use the power of a power property to solve equations with rational exponents. Now we're going to use power property. So what's the solution for 27 to the power of x minus 4, which is equal to 3 to the power of 2x minus 6? They don't have the same base, do they? But you can make it into the same base. How do you do that? You're going to rewrite 27 by a base of 3. You know that 27 is 3 times 3 times 3, which is 3 cubed. So 3 cubed, parentheses, to the power of x minus 4 is equal to 3 to the power of 2x minus 6. And so you can use the power property to multiply your powers and get 3x. So that's distributive property as well. 3x, because 3 times x minus 4, you need to use the distributive property to get 3x minus 12, right? So that's your power. And since your bases are the same, you can get rid of the base and say the powers must be equal to each other. 3x minus 12 must be equal to 2x minus 6 if the whole values are equal to each other. Right? And then you're just going to solve for x, subtract 3x on both sides, add 12 on both, 6 on both sides, and then divide by -1. You get x is equal to 6. Solution is 6. Okay. All right. So another example. What's the solution of base that's a fraction? 1 over 125 to the power of -x over 2. Wow, there's all kinds of complications here. Your base is fraction, your power, your exponent is negative. That's okay, guys. That's okay. Just do it step by step. All right, so you're gonna rewrite your bases as powers of 5, okay, with a negative exponent, because you know that 1 over any base b is equal to base to the negative. So base with the nth power is negative nth power. Yeah. So change your fractional base to a negative power. 1 over 125 is equal to 1 over 5 cubed. 5 times 5 times 5. And then that's equal to 5 to the -3. Okay, and then 1 over 25 is also written as 1 over 5 squared, and that's 5 to the -2nd power. Okay, use the negative exponent rule. And then you're gonna rewrite your equation using your powers of 5. And then you can multiply the powers using powers property. And since your bases are the same, so the whole idea is that you get the bases to be equal to each other. Okay. And then since your bases are the same, you can let your powers equal to each other and solve for x. So step 2, write the exponents as an equation, and you're going to solve for x. You will get 4.5, and that's your solution. Okay, you can do it. I know it looks more complicated than you're used to, but if you get enough practice, you'll get it. So let's look at try number 3. What is the solution of each equation? Okay. So think about your goal for this example 3. Your goal is to make the bases the same so that you can get rid of them and make the powers equal to each other, because when the values are equal and you have the same base, there's only one power you can satisfy, right? That makes the values equal. So try making 256 into a base of 4 or 2, right? Because 4 is also 2 to the power. It could be written as a base of 2, but it could either be written as a base of 4 or 2, your choice. Same for that one. That one, you need to write it in base of 2. So see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? So let's look at part A. I'm gonna write it over here, part A. So 256 is 4 to the what power? 4 to the 3rd power is 64. 4 to the 4th power is 256. So 4 to the 4th power is 256 to the power of x plus 2. That's equal to 4 to the power of 3x plus 9. And then use the powers property to multiply your powers out. 4 times x plus 2 is equal to distributive property 4x plus 4 times 2, 8. And so 4x plus 8 is equal to 4 to the power of 3x plus 9. That means your powers, your exponents need to be equal. So 4x plus 8 is equal to 3x plus 9. So solve for x, subtract 3x on both sides, and you get x plus 8 is equal to 9. Subtract 8 on both sides, you get x is equal to 1. That is your solution for part A. Not too bad, right? Not too bad. Part B. What about part B? Okay. So let's rewrite that 8 into power of 2 because you can't write it in the base of 4, right? 4 squared is 16. So like it's more complicated. So 1 over 8 is equal to 1 over 2 to the power of 3, right? X over 2 minus 1. And then 1/4 is 1 over 2 squared, x over 3. And then you're going to rewrite this as a negative exponent. 1 over 2 cubed could be written as what? 2 to the negative 3rd power. Okay. And then what about 2 squared? 1 over 2 squared. Same thing, 2 to the negative 2nd power to the power of x over 3. And then you're going to use the distributive property to multiply this out. Right? So your powers are going to be negative 3x over 2 plus 3 and negative 2x over 3. So you're just going to set them equal to each other. Negative 3x over 2 plus 3 is equal to negative 2x over 3. And so add 3x over 2 on both sides. And then you can get rid of that. That's 0. And 3 is equal to negative 2 over 3x plus 3 over 2x. So that means 3 minus 2, wait, they don't have the same denominator. So rationalize your denominator. Let's go down. Rationalize your denominator. That is 2. So let's make it a 6. So negative 4 over 6x plus 6. Wait, no, 9. Just multiply by 3. 9 over 6x is going to be 9 minus 4 is 5. So 5 over 6x. And so multiply both sides by 6 over 5, the reciprocal. And then you'll get 1x. And x is equal to 3 times 6, 18 over 5, which is also 3.6. So part B is 18 over 5 or 3.6. Your part A was x is equal to 1. Okay. All right. Let's look at the last question, application part. Wait, we have one more example. Okay, so we have 2 application examples. Let's look at example 4. Use the power of a product property to solve equations with rational exponents. Adam is setting up for an outdoor concert. He places 3 square blankets near the band as shown in the picture. What is the area of blanket C? All right. So the blanket C has an area of x yards square. And you know this tiny blanket is 12 yards square. And then blanket B has 8 yards square. So how do we figure out? How do we figure out what the area of blanket C is? Well, try to look for relationships. The area is length times width, right? So the length over here and the width over here equals to 12 yards square over here, right? So the length here, there are all squares, right? The blankets are all squares. So we know that the sides are going to be equal. So square root of 8 is going to be one side of view, right? Square root 8 is also written as 8 to the power of 1 square. And x, square root x is also x to the power of 1 over 2. So that's your length and that's your width of this area, right? So this area where they're playing is 12 yards square. And you're gonna write an equation using that and solve for x. And that's the area of the blanket C. X is 18. So the area of the blanket C is 18 yards square. You can check the answers by multiplying the square root of 8 and square root of 18 to get 12 yards. All right, let's look at try number 4. When the side length of blanket A here is multiplied by 2 to the power of 1/2, the result is 6 yards. Find the area of blanket A. Okay, see if you can figure it by yourself. Come back when you're ready for answers. Okay, are you ready? So we don't know what the area of blanket A is. We don't know what size blanket A has, right? So there's really no information. You can just say X for a side or X for the area, right? So whatever you don't know or you want to figure it out would be the variable. So when the side length of blanket A, we can say the side length X, okay? X is multiplied by 2 and 1/2, 2 to the power of 1/2. The result is 6 yards. So find the area. The area is side square, right? So using that, we can say the area is going to be side x squared. So first figure out the x. X is equal to, well, let's think about this. That's gonna be x times square root of 2. That's equal to x, which means you can divide by square root of 2 on both sides to get x, right? So x is 6 divided by square root of 2. What does that really mean? 6 divided by 2 to the power of 1/2. What does that really mean? Right? So 6 divided by square root of 2 is irrational number, irrational denominator. That's okay. And we know that x is 6 over square root of 2. We just figure out the area by squaring the x. 6 over square root of 2 square is 36. And what's square root of 2 squared? So if you square the whole thing, you can't just square the top, the numerator. You also square the denominator, okay? Because it's squared on the whole fraction. That means it's 36 over square root and the power 2 cancels each other out is 2. So 36 divided by 2 is just 18. So the area is 18 yards square. All right. So set up an equation, figure out your missing variable, and answer the question. Let's look at the last example. Use the quotient of powers property to solve equations with rational exponents. Terrarium A and terrarium B are cubes. it means that all the dimensions are equal, like the sides of all the squares are equal. The side length of theorem A is twice the side length of theorem B. What's the value of x? So first, write a proportion using the side lengths. The side, the ratio of the side lengths is 2, because if you multiply the side of the small theorem B, you'll get the side of theorem A. So 2 so this is your volume, which means you multiplied one side times another side times another side. So you need to square. You don't square root it, you cube root it to get the side. So the side for this cube is going to be 2x cube root, which is also written as 2x to the power of 1/3. Okay, that's why we have that one. The side for this one is 2 to the power of 1/3. Okay, because that's the volume. So the side for this over the side for that must be 2. That's the ratio, right? Or you can say this side, 2 to the power of 1/3 times 2 is equal to this side, 2x to the power of 1/3, because yeah, it's double the smaller side. Okay, and then since the bases are the same, you can use the product of powers property and get 1/3 plus 1. If you don't have a power, that's 1. That's equal to 2 to the power of powers property says you can multiply them, so x/3. Okay, and that means you have 2 to the power of 1 is 3/3, so you get 4/3, which is equal to x/3. So your bases are the same. You can get rid of them and say 4/3 must be equal to x/3. And your denominators are the same. That means x is equal to 4. Okay. So your x is 4. The value of x is 4. So what is the value of x if the side length of theorem A is 4 times the side length of theorem B? Then instead of twice the length, what if it's 4 times? So you write the same equation and solve for it. So instead of timing by 2, you're gonna times it by 4 times this side, the smaller side, by 4 to get the bigger side, right? So this is try number 5. 2 to the power of, what was it? 1/3 times 4 is now the side for that one. 2 to the power of x to the power of 1/3. Okay, and now you solve for x. And so you can write 4 as a base of 2, since our goal is to match all the bases, right? So 2 to the 1/3 times 2 squared is equal to 2 to the power of x/3. Yeah? And since the bases are the same, product of powers, you can add the powers and say 2 to the power of 1/3 plus 2 is equal to 2 to the power of x/3. And 2, so that just means 1/3 plus 2 must be x/3. And 2 is really 6/3. So you have 7/3, it is equal to x/3, and your denominators are the same, which means x, you can multiply 3 on both sides and get rid of the denominator, and you can say x is equal to 7. Okay, so use the same rules and you'll get there. All right, so let's summarize our lesson. So here's a summary. Here's a nice summary of the rules of exponents. We have a power of power property, power product property, power of powers property, quotient of powers property. So these are the variables, and m and n are different powers. And numerically, these are the examples that you can see of those properties. And just remember the nth root of a real of your base A is a real number and m is an integer. Then you can say the rational power could be the square root with the same denominator as an index. And then if you have a rational number of m over n, your m, the numerator in the power, would be the power of your exponent of your base, and then your denominator is the index of your square root. Okay. Also, your negative power makes, I don't think there's the negative. I'm going to add the negative exponent rule. Rule says that if you have base A to the power of negative m power, that gives you 1 over A to the positive m power. Okay, so for example, 2 to the power of negative 2 is equal to 1 over 2 squared. And so that's 1 over 4. Okay, so remember these properties. Also, there's a 0 property. Any base to the power of 0 is 1. 100 to the power of 0 is 1. All right, guys, that was lesson 1, our very first lesson of topic 6, rational exponents properties and exponents. So in the next lesson, we'll talk about exponential functions. All right, thanks for watching, guys. If you have any more questions, please ask Ms. King in class. Bye.